There are always three factors that influence how a circuit operates: voltage, amperage, and resistance. Let's take a look at voltage. Voltage is best described as electrical pressure. To better understand this definition, it helps to remember what electricity is: the movement of electrons through a conductor. Voltage is the electromotive force that acts on the atom to move electrons from one atom to the next. Automotive circuits use a battery as a power source. A battery has a positive and a negative terminal. Negatively charged electrons are pushed away from the negative terminal and pulled toward the positive terminal. If we increase the difference between positive and negative, in other words, increase the voltage, we will increase the potential for the flow of electrons. The greater the difference between positive and negative charges, the greater the electron flow. In the same circuit, higher voltage means more electrons will be moved, while lower voltage means fewer electrons will be moved. This is also called a difference in potential. In a simple electrical circuit with the switch open, a difference in potential exists between the switch contacts even though no actual connection is made. The potential for current flow is there even if the lamp itself is not on. A battery has the potential for doing work, such as operating the lamp. To measure voltage, a voltmeter is used. It is used to measure the difference in electrical pressure between 2 points. Amperage is a measurement of electrical flow. It is the movement of electrical charges from one point to another. A current flow exists when we have a difference between positive and negative charges, and the electrons begin to move in an orderly manner. Voltage causes the movement, and amperage or current is the result. Now let's look at the final factor affecting a circuit's performance: resistance. Resistance is the opposition to current flow in a circuit. Copper and other conductors offer low resistance to the flow of electrical current, while rubber and other insulators offer high resistance. The electrical unit that we use to measure resistance is called the ohm and is measured by an ohm meter. Many factors influence the resistance in a circuit. The size, length, and temperature of a conductor will affect its resistance. Let's take a look at these one by one. The diameter of a conductor will vary its ability to carry current. If you look at the major appliances in your home, you will see that the electrical cables are larger in diameter than those found on smaller appliances. These cables will have less electrical resistance and allow more current to flow. Another factor influencing how current travels through a conductor is its length. Remember, even though copper is a good conductor, it still has resistance. If you look at the size of the wires that connect the battery to the cranking motor, you will notice that they have a very large diameter and are relatively short. The final factor that may alter a circuit's resistance is the temperature of the conductor. Most conductor materials, like copper, have a positive temperature coefficient. That is, as the temperature increases, so does the resistance of the conductor. As the temperature drops, so does the resistance of the conductor. In most simple circuits, the variation is minor and causes little change in circuit operation. As a wire is heated, you can see that the resistance reading on the ohm meter rises slightly. Some materials, such as carbon and other semiconductors, may behave in a very different manner. They have a negative coefficient and have lower resistances as they heat up. The air temperature sensor is called a thermistor. This is a resistor that is designed to change with temperature. These are often used in automotive temperature sensing circuits. Other components are designed to cause variations in resistance that change the current or electrical pressure in that part of the circuit. These common carbon-type resistors, for example, are rated by differences in their resistance. The color bands around the resistor's outer diameter indicate resistance. The color code can be compared to a chart to determine the exact resistance.